Rick.
Good afternoon all. So evaluating the price of a single good across different countries illustrates the magnitude of price deviations that occur globally. This shows the challenge of disentangling the international dimension in relative prices. Nevertheless, the analysis we've conducted in this paper will help us gain a slightly better understanding of international price behavior, which is a step toward gaining insights into how price movements are transmitted across borders. This knowledge is crucial information when it comes to the proper functioning of monetary policy. In order to conduct the analysis, we've constructed a novel panel dataset consisting of Apple product prices. So first of all, just a basic refresher on the law of one price and purchasing power parity. From basic economic theory, the law of one price states that in competitive markets, free from transaction costs and any trade barriers, identical goods in different countries should trade at the same price when expressed in a single currency. If we let PIXT signify the local currency price of a good X sold in country I at time T and the nominal exchange rate of that country to the US represented by capital E, then the price ratio of the two goods should be equivalent to the nominal exchange rate. This, however, is rarely observed, for example, the Big Mac index. This is because we assume the goods analyzed are 100% tradable, there are zero transaction costs, and that there are no time lags or any other price rigidities. Under these assumptions, any deviation from this equation should immediately result in a potential arbitrage opportunity until the single price again prevails within the two markets. We can now reformulate this theory as a generalized equation in logarithmic form, and by adding alpha and beta parameters, we can express it as an estimatable equation. That is, the difference between the logarithmic domestic price and foreign or US price should equal an alpha parameter plus beta times the logarithmic nominal exchange rate plus an error term. For the relative law of one price to hold, beta should equal 1, while for absolute law of one price to hold, both alpha should equal 0 and beta should simultaneously equal 1. If there are any transaction costs, these should be captured in the alpha coefficient and or the error term. So why do we suggest we should use Apple product prices to analyze these exchange rate pass-through equations? In a seminal paper by Rogoff in 1996, he indicated that it appeared as though a consensus was finally being reached within the purchasing power parity literature that even though real exchange rates were found to converge to parity in the long run, deviations from the law of one price or purchasing power parity were still extremely persistent, at least much more than what rational expectations or other possible rigidities and arbitrage costs would potentially predict. Specifically, according to Rogoff, the estimated half-lives of real exchange rate deviations were in the vicinity of 3 to 5 years. This he dubbed the purchasing power parity puzzle. One of the limitations and causes of several disputes surrounding the law of one price and purchasing power parity studies has therefore often been on the data sets themselves used to test these theories. Due to their availability, most of what we know surrounding real exchange rates originates from studies that use some variant of aggregate price indices, specifically the consumer price index. Some of the benefits of conducting a study on the law of one price, and specifically pertaining to Apple products themselves, include: first of all, each product is a completely homogeneous good. This is compared to the heterogeneous weights in goods used in other aggregate price measures. Second, the products are tradable. Aggregate price indices often devote a significant weight to non-tradable goods and services, while as seen from earlier assumptions, the law of one price or purchasing power parity can only hold for tradables. Actually, even the supposedly tradable products in these composite price indices often incorporate a notable non-tradable component. For example, the products sold at the local retailer also embed the input costs of both local wages, rent, electricity, etc. Third, there is no product or time aggregation bias. Taylor in 2001 showed that when price data are averages and collected at discrete points in time, that is, the way aggregate price indices are generally constructed, the persistence of real exchange rates may be overestimated. Eames et al. In 2005 have also investigated a so-called aggregation bias, causing positive persistence in real exchange rates due to their underlying components having heterogeneous dynamics that vary with the characteristics of goods. According to the authors, it is difficult to foresee why various products in price indices should all converge to parity at a similar speed. Fourth, law of one price studies have derived real exchange rates that can be measured in price levels. This actually yields an implied exchange rate. For price indices, however, one has to pick a specific base period where purchasing power parity is assumed to hold. So some of the additional benefits of using Apple products include the products are widely available internationally, which helps add power to analysis with larger cross-sections we can compare. The products also have a single point of origin, that is, they are manufactured in China or Taiwan and then are shipped from there. As such, the most significant non-tradable component of their prices are attributable to these specific countries, which is exactly the same for all products. Finally, since it is a specific technological product that's imported by each country and sold by the country's respective online iStores, transaction costs, specifically taxes, tariffs, and even shipping costs, can be measured or at least estimated and controlled for. So this table summarizes our regressions on exchange rate pass-through using various relative price measures. Panel unit root and co-integration tests were first performed on the various relative price and exchange rate measures. The individual price and exchange rates appear to contain unit roots, while the overall exchange rate pass-through relationships were generally found to be co-integrated. Then for each relative price ratio measure, that is CPI, Big Macs, as well as Apple products, 5 different panel regression models were estimated. First of all, simple pooling, country-specific fixed effects, time period fixed effects, combined country and time fixed effects, as well as random effects. A summary of the most appropriate panel regression methods, that is first testing whether fixed effects are redundant, and subsequently using the Hausman test to decide whether fixed or random effects models should be used, are then shown in this table. Despite the prominent alpha parameter coefficient estimates for the iPod and iPad datasets, the relative law of one price appears to hold fairly well for these two products under these regressions, with both betas close to parity. Even though the iPhone price ratios perform well in the pooled and random effects models, which is not shown in the slide, this price ratio fares notably worse once country fixed effects are included. Overall, the CPI ratios and Big Mac prices do not appear to adhere to purchasing power parity except in the pooled panel regressions. Following the initial evaluations, one can now also evaluate how the parameter estimates change once transaction costs are also included. So this following table summarizes our regressions on exchange rate pass-through using various relative price measures, but including also transaction cost measures. So this is done by adding transaction cost measures on value-added tax or general sales tax, import tariffs, and shipping rates. In the equation that's estimated, tau IXT is the associated VAT or general sales tax rate that country I levies on product X at time T. Iota IXT represents the import tariff rate country I imposes on good X at time T on imports originating from China, and lambda IXT represents the estimated shipping cost rate from China to the respective importing country I. Counterintuitively, for Big Macs, the alpha interceptors actually increase from about 0.6 to 0.87 after including local VAT or general sales tax rates, while there was no noticeable impact on the beta parameter. This means that after including the impact of local taxes, the only transaction cost variable that we can easily control for on Big Macs, this price ratio now sees even less adherence to the notion of the law of one price. Meanwhile, for the iPod relative price to ratio, a notable decrease was observed in the alpha parameter. In fact, it's no longer statistically significant. Also, the beta for iPods gets even closer to unity after including the logarithmic relative rates on taxes and tariffs. Both of these two transaction costs are also found to be statistically significant and have the appropriate signs. For the iPad price ratios, adding transaction costs to the specification did not noticeably decrease the alpha parameter in the fixed entity and time effects model. Specifically, once fixed effects were added, the intercept remained fairly large and the beta coefficient also slightly less than parity. That said, for the pooled and random effect specifications, again not shown, the intercept dropped significantly once transaction costs were accounted for, and the coefficient estimates were also in line with those obtained from the iPod price ratio. This could potentially indicate that the tax or tariff ratios contains some cross-sectional information that interacts in the regressions in the iPad datasets. Finally, for iPhone prices, VAT or general sales tax rates were found to be a statistically significant contributor to the relative price ratio, and by adding the transaction costs, it notably decreased the alpha parameter from about 0.55 to 0.38 in the most appropriate country and time fixed effects model shown. Again, similar to the iPad data, the pooled OLS and random effects specifications were more supportive of the law of one price adherence for the iPhones. Nevertheless, iPhones are still notably more suited than Big Macs or the Consumer Price Index in terms of adhering to the law of one price or purchasing power parity, at least from this panel data regression analysis performed. Overall, some of the specifications appear to be quite sensitive regarding the effects, that is, fixed or random, that was used. The results in the study appear to be in contrast to that of Click's 1996 paper that concluded a similar analysis on Big Macs on a dataset ranging from 1986 to 1995. His finding was that the failure of purchasing power parity was due exclusively to time-invariant country effects. However, in this study, when including these fixed effects for countries, the Big Mac index does not appear to come close to adhering to the law of one price over our time period, that is from 2007 to 2020. In fact, for most of the price datasets, our findings are exactly the opposite to that of Click. More specifically, after including fixed country effects, the panel regressions performed notably worse, particularly for CPI and Big Macs, in these price measures' adherence to the law of one price or purchasing power parity. Thus, having conducted numerous panel regression models, it appears as though iPods, and to some extent iPads, adhere fairly well to the law of one price. PyMC3 is a library package that's available in the Python programming language. By utilizing this package, it's possible to run Markov chain Monte Carlo algorithms to construct a Bayesian generalized linear model to evaluate some of the exchange rate pass-through relationships that we've specified earlier. By using this alternative statistical approach, it is possible to re-specify the earlier equations to evaluate it in terms of a probability distribution function. According to the specification, the logarithmic price differential equation is now formulated as a random vector of which each element is distributed according to a specified statistical distribution, in this case a normal distribution. The mean of this normal distribution is simply our linear predictor, that is alpha plus beta times the logarithmic exchange rate with a variance parameter. In our priors, we've assigned a fairly wide standard deviations as well as a high level of uncertainty for our overall model. Specifically, the prior distribution for the variance parameter is defined as a half normal 0-1 distribution. For the alpha and beta parameters, it is normal with expected values of 0 and 1 respectively, and each with a standard deviation of 0.5. We also check the robustness of this Bayesian analysis by including a large array of various prior specifications, and the models prove to be fairly robust to different prior specifications. By deploying the Markov chain Monte Carlo algorithms on these prior distributions, we are equipped to quantify uncertainty by obtaining posterior distribution of how likely each value of the parameters are. We subsequently draw 4,000 posterior samples from 4 chains for this model and plot the resultant marginal posterior distributions of the parameters for iPods as an example. The narrower the posterior distributions, the more certain we are that the model we have defined fits the actual data. What's more, by using these BGLM models, we can also evaluate the evolution of the parameter distributions when we account for transaction costs. By performing this Bayesian analysis on all of our price ratios, we can then plot the posterior distributions for the betas in a violin plot. So you can also see the blue shaded areas is the beta distributions where transaction costs were excluded, and the gray shaded areas is the beta distributions where transaction costs were included. Overall, the betas have not been noticeably impacted by the inclusion of these transaction costs. Specifically, when evaluating the pre and post transaction cost inclusion effect on the distributions of the parameters themselves, neither the CPI or Big Mac betas include unity in their distributions. Meanwhile, for all of the alpha product price measures, their respective beta distributions include 1 within their posterior likelihood distributions. What's more, for most, the means are close to unity, both before and after including transaction costs. Even more interesting and noteworthy from these analyses is that the alpha parameter distributions for the Apple product price datasets have shifted significantly closer to zero following the inclusion of transaction costs in the BGLM specifications. This finding supports the notion that after controlling for the impact of transaction costs, the Apple product price measures adhered notably better to the law of one price. In fact, for the Apple product price datasets, the alpha distributions now include naught when input costs are accounted for, though it must be added that all of the alpha parameter distributions have widened somewhat, indicating more uncertainty after these cost measures have been included. Finally, this figure uses a joint kernel density plot of the Markov chain Monte Carlo generated alphas and betas for the Apple product prices. Again, this chart clearly illustrates how the betas are distributed around 1, both before and after including the transaction costs. But the alphas have shifted noticeably lower after transaction costs were accounted for. In addition to the absolute law of one price and purchasing power parity specifications defined in the previous slides, we can also control for the heterogeneity of the alpha parameter by estimating the following H-period difference equation. The H-period difference is simply the current logarithmic domestic foreign price ratio minus the logarithmic domestic foreign price ratio H periods earlier. The same applies for the exchange rate. This evaluation is an informal method of testing whether the derived real exchange rates are stationary or at least converge to some constant over time, since the movement in the nominal exchange rate should approximate the change in the relative prices. By estimating each beta hat over each extended time frame, that is h plus 1, one would be able to assess how much of the dispersion between various relative price measures and exchange rates decrease over time. These figures illustrate with regression plots how the beta hat parameters evolve for CPI as a relative price ratio measure when the time frame is extended by 1 year at a time from h equals 1 to h equals 8. And you can see clearly that initially you start off with a very low slope with beta approximately 0.16, and the regression fit is also not that great. But as you increase these H periods from 2 years, 3 years, all the way up to 8 years, you can see how the betas continue to increase all the way for CPI in this case to about 0.57. The same analysis is then conducted for Big Macs, and the betas are slightly higher. And the most interesting thing is when you continue on to the Apple products, you can actually see that these dots converge to these slope lines much quicker and much better than in the other price baskets. For example, after about 5 or 6 years, you can see the beta estimates have approached 0.9 and then increased to about 0.1 or to parity after about 7 years for the Apple products. This specifically is the iPods. And then I've included the summary measure for all these different beta parameters over the different time periods. This is the chart that summarizes all these estimated beta parameters from 1 to 8 years for the different price ratios, which clearly illustrates how much quicker the Apple product relative price ratios and exchange rates converge to unity over time. In fact, for H equals 6, the beta for iPods and iPads have reached almost parity, while the comparable estimates for Big Macs and CPI do not even reach 0.66 over an 8-year period. Though the relative prices on iPhones converge slower to unity than iPads or iPods, it is nevertheless noticeably quicker than for CPI and Big Macs. Overall, the data supports the hypothesis that the law of one price holds for some Apple products in both absolute and relative terms, as well as across a range of estimation methods, especially after controlling for transaction cost. Apple prices are better suited than often used alternative price measures to investigate international parity conditions, for example, the CPI index and consumer price index. Thanks for your time.
Thank you. Thank you very much, Rick. Okay. Very nice, very interesting. The question, I think, the natural question is, there is a difference between iPod and iPad, between products from a single company that are distributed around the world, using labor and productivity from one single source, relative to prices of the same good, but produced by different labor, different. Cioè, what are we measuring here with the iPads? We measure the extent at which a company is unwilling, if you want to allow different prices. For example, prices in euro and prices in dollar of iPad of Apple products are only expressed. If it's $1,000, is €1,000. Although there is not absolute parity between the two, therefore there is a sort of pricing to market there, and how you disentangle what is an adjustment process to exchange rate to a pricing to market that maintain the price as close as possible to each other.
So I think in a later paper we'll definitely evaluate exactly how much pricing power Apple has to these different economies. But I think what's interesting is that even though we want to assume Apple does have pricing power within these different countries, it seems that after you can control for a lot of these transaction costs, the law of one price actually prevails exactly. Not for iPhones, but there is maybe a good reason for that. But for iPods and iPads particularly, it seems that after controlling for that and for the different import prices, then it does look like the prices are exactly equivalent. So even though initially it appears that the one product is $1,000 in the States compared to 1,000 euros in Europe, if you control for the different tax and import tariff rates for those two economies, it actually, and as well as transaction or transport costs, it actually shows the prices are matched exactly after taxes and transport costs. The reason why iPhones appears doesn't adhere to the law of one price as well as the other two products is it seems that these telecommunication, all these telecommunication companies had different deals with Apple in terms of how to price those different products. So that's why the law of one price potentially does not hold as well for iPhones.
That's a good point. Exactly what I was saying. How much is the fact that Apple want to price each anywhere in the world they want to earn the same amount in dollars? And therefore, if you want the price of in dollars of what you sell to remain the same,
yes,
you will tend to adjust the local price for any change in exchange rate. Therefore, your low one price is you have variation exchange rate, and Apple takes a while to adjust because your beta is much faster. Let's say the Big Mac.
Yes, exactly.
Why instead, when for iPhone, because there is a more complex market, they have less, if you want, market power because they have to do deals and there is other big player. They have less, and therefore there is less. Could also be this one the interpretation of why iPod and iPads work.
Exactly.
Therefore, it's not how much is a deviation are indication of overvaluation of undervaluation of the exchange rate, for example. So would you use it like the Big Mac index as an indicator of overvaluation of undervaluation?
So I think in our second paper, we are going to look at exactly how the real exchange rate deviations, how that could potentially be used as currency forecasts compared to a random walk model as well. So I think this paper was just the initial introduction into the iPad and iPod databases and to see how well, after including these transaction costs, the law of one price is actually observed. But in subsequent papers, we'll also see how the exchange rates adjust or how real exchange rates adjust according to any shocks or deviations from parity. And from my initial findings, what was interesting, so as mentioned in the Rogov paper, Purchasing power parity by CPI indices appear to indicate that real exchange rate deviations' half-lives range between 3 to 5 years. From preliminary investigations, it looks like the half-lives could be significantly less than half a year by looking at a well-traded product like iPads or iPods, for example. So, and that's not even taking the non-linearity of exchange rate deviations into account, which means that these deviations could be even noticeably shorter. So obviously you're not exactly comparing the same product, but again, it just shows you if you use the right product and you can control for all of the transaction costs, some of the basic economic theories explain some of the data quite well.
One last thing, can you explain a bit more the construction data set?
So basically, there's this amazing website called the Wayback Machine. So that takes snapshots of every website or every frequently used website and archives it. So I use the scraping plugin in Python and scrape the Wayback Machine's snapshot of iStore prices on all of these different devices going through history. So this initial data set is only from about 2007 to 2020, and I think iPods dropped off around 2017. But it was an annual data set that I scraped on about 50 countries over these last 13 years. And in a subsequent paper, we're going to look at a more high frequency data set that we can scrape weekly, comparing all these prices. And if the iStore didn't have that specific product's price, then we'll look at an authorized general Apple reseller within that country to get the appropriate price.
Great, thank you. There is a question by Dawi. If you want to bypass the idea of telecom unlocked prices, could you consider the prices of unlocked iPhones?
So I think the problem is looking at products like unlocked iPhones. I did use it when it was available, but it was definitely much more difficult to navigate all those different retailers or the telecom resellers' website to scrape the data on iPhones. So often also you'll have to use Google Translator to see that specific website. It's not always exactly clear. So I think that's the reason why we also observe the beta parameter not fitting as well as it should. It's because I think the data is also much more noisy and much less comparable to some of the other products that are much clearer. But I think in theory, if you do look at unlocked phones, I think the law of one price should hold up much better than I currently found within my dataset, just looking at unlocked phones.
Rick, thank you very much for the presentation. It was great.
Thanks, guys.
Thank you, Rick.